We observed crazy behavior in the beer game, right? And the orders were fluctuating all over the place. And I'm going to try and explain what was happening in the beer game simulation. So, the beer game simulation is a demonstration of the bullwhip effect, where we say that the variability increases as we go upstream the supply chain from the consumer to the retailer to the wholesaler and distributor factory, whichever is. So consider a toothpaste. As a consumer, I have very uniform consumption of toothpaste day to day. But my purchase has variability. So I'll go out, purchase a 3 pack of toothpaste today, and then nothing for a couple of months, and then again go out buy 3 packets. So as the consumer, my purchase or my supply side has more variation than my demand side. Same thing for the retailer. Retailer doesn't purchase every day. They would have nothing, and then suddenly they would purchase maybe 10 cartons of toothpaste. So retailer has the same variability increase as it goes upstream. The supplier to the retailer, who could be a factory, would have a similar situation. So, and this would manifest itself as an increase of cost as we go along the supply chain, right? And we very clearly saw this in the bullwhip effect. All of you, when you check your numbers, you would see this. So, for example, in the table first up, we see that the costs, because variability is equal to the cost, or variability causes cost. Cost increase as we flow upstream from the retailer to the factory. The retailer in this case had a cost of around $61, and the factory had a cost of $8,400 to serve the same demand. And even within a particular entity, I say this is a graph of a particular warehouse. I see that the warehouse demand variability is substantial, which is the red curve, is substantially lower than the warehouse's supply variability, which is the blue line. So warehouse's purchase has more variability than warehouse's demand, okay, which is causing the bullwhip effect. Now let's see why this bullwhip effect happens. Why does the supply side become more variable than the demand side? So think of this as a supply chain, a toothpaste that we were talking about. So the multiple channels, toothpaste is bought from a retailer who gets it from a wholesaler who gets it from a factory, and the factory has its own supply chain where I could have product like caviar gum, which is an organic product, comes from trees. I could have a binder like hydrated silica, which comes from a factory which has its own supply chain. I could buy plastic pellets, which to make the paste, which has again a factory and its own supply chain. And what happens here is I've just mapped a part of the supply chain, but if I look at something like let's say hydrated silica, well, hydrated silica does not supply only to toothpaste manufacturers. They have multiple uses. One of their uses is also Atomaceous earth, which is an insecticide. Plastic pallets similarly serve multiple industries. They could serve all these bottle makers, cosmetic makers, plastic phone cases. So the real supply chain is very complex. It's a network which is very difficult to trace and manage. So a hypothetical solution to beer game, to not having these variability problems, is to get everybody together in this network. And then I start telling customers that, hey, you know what? The longest lead time to make apparels is cotton, and cotton takes about 3 to 4 months to grow. So all your apparel needs, you need to tell me 4 months in advance. So when you tell me 4 months in advance that this is the particular apparel you need, well, that's when I'm going to go to my farmer and tell plant so much cotton, and then I'll plant a factory to convert the polyester into cotton and then merge it with polyester or whatever. I know this is an absurd idea, but I wanted to make it absurd. The idea we cannot survive like that. It's impossible to get everybody in the room and get firm 6 month, 3 month, or a year commitment from people. So what we do is every factory, every entity tries to make a smaller version of the earth and make itself as the center of attention or the center of the earth. And then it says that, I'm going to focus on my own profit because getting everybody together is not possible. And then I look at my own demand as the independent demand. So think of this. For the plastic pellet manufacturer, the demand for pellets is in part because of the demand for toothpaste. All right. So, the plastic pellets is not an independent demand. It's a dependent demand. But if I'm a plastic pellet manufacturer, what I'm going to do is those pellets, which are formed into into those toothpaste cases or toothpaste tubes, I look at that as my independent demand. I look at the orders placed by toothpaste companies for plastic pellets as my independent demand, and forecast that independently of everything. Okay, so I'm not concerned by consumers' consumption of toothpaste. And then I know there'll be variability. This is not a perfect way to live, so I build buffers and survive by creating buffers. Now these buffers are what are the most interesting part and real causes of bullwhip effect. So buffers have multiple reasons, but we can say three reasons. Reason number one is trust. If I trust my supply chain partners, trust their orders, trust their future views, well, I'm going to maintain substantially lesser buffers. Two is my packet size or batch size, which is usually linked to lead time. Because if I order something from a distant land, I would want to order in bulk. I won't order in parcels. I'll order in containers. So I get larger pieces at one time. So I'd have to maintain higher buffers in that scenario. And the third is the inherent variability. If I'm not sure about what's happening, I would have higher buffers. So think of this, it's easy to imagine it as a pipeline. And the length of the pipeline is the length of, you can say, lack of trust or batch size or lead time or variability, whatever. So I have, as a factory, I have these two pipelines. In first pipeline, the demand is 6 units per day. And the 6 units per day, the variability inherent is, I figure that 10 days is the inherent variability. So I decide to hold a buffer of 60 units. In the second pipeline I have, there is 4 units of day demand, and I decide to maintain 20 days of buffer. So my buffer stock is 80 units. Now, my daily production is 10 units per day, but I maintain a buffer of 140 units per day, right? It'll keep coming. The buffer will keep going up and down, but I'm producing 10 units per day more or less uniformly every day. Now, let's assume there is a perception that the demand has gone up by 1 unit per day. Okay, some reason the demand goes up by 1 unit per day. And when the demand goes up by 1 unit per day, I also now think so my production should ideally increase from 10 units to 11 units, which is a 10% increase, which is fair. So my demand has gone up by 10%. But now my immediate challenge is not just to increase that from 10 to 11, but I also need to fill that pipeline, which is 10 units, right? So my immediate target to my production is the 11 units plus the 10 units required to fill up that new pipeline, so which is 21 units. And I'll purchase stuff needed for 21 units. So what we saw, my demand went up by 10% from 10 units to 11 units, but my purchase went up from 10 units to 21 units, which is an increase of 110%. Okay, and this increase, same thing would happen whenever there is a reduction on the demand side. The reduction in demand side may be a little bit, but I will try to empty the entire pipeline, and so my supply side reduction would be even higher. So this is what we see in the Beergame simulation that we played. And because it's not about how good or bad I am, but there is a natural tendency to increase the supply side variation as compared to the demand side variation, and which causes what we call as the bullwhip effect. So this brings us back to this original idea of why supply chain management. That instead of me as a company focusing on my individual demand, putting myself as in the center of the universe and focusing independently, maybe I can use technology. Maybe I can use some form of collaborative techniques to get more, as many as people as I can together, and we do our planning together as one group. We could substantially reduce the bullwhip effect, substantially reduce variability, and substantially reduce the costs that we have in the supply chain.